All right, so we'll do a review for the test tomorrow. Test is just going to cover 10.2, 11.1, and 11.2. Actually, test not tomorrow. Test is Friday. If I say tomorrow, I mean Friday. So any questions on the elimination with matrices? Anyone want to see one of those?
Yeah.
All right. So let's, you want to do a 2 by 2 or 3 by 3?
Let's go ham.
3 by 3.
Yeah.
All right. So I'm going to pick one from the book. All right, so solve. And it'll say something like solve using Gaussian elimination. That's just a fancy way of saying solve it using the stuff we did with matrices. So let's say we had 1, -1, 1, 0. Any questions on how to get the original matrix? Like how I'm looking at the equation, it said x minus y plus z equals 0.
Yeah, no, it's just.
You just take the coefficients.
Yeah.
So the original one was x minus y plus z equals 0. 2x plus 0y minus 3z equals -1. And the last one is -x minus y plus 2 equals -1. All right, let me just double check. 1, -1, 1, 2, 0, -3, -1, -1, 2. It looks good. All right, so what's the goal? Even if you don't have to, well, what's the overall goal when you have a matrix?
You want to put it in its form.
Yep, the row echelon form. And what does that mean?
Which means that the row 2 and 3 in column 1 are going to be zeros. And then you want rows 2 and 3, column 2, you want both of those to be, you want row 2, column 2 to be a 1 as well.
Yep.
And then you want row 3, column 2 to be a 0.
Yeah.
And then you want row 3, column 3 to be also a 1.
Yes. So for a 3 by 3, it's exactly that. In general, you just want to get 1s on the diagonal, 0s below. That's the goal. Okay? In general, 1s on the main diagonal, 0s below. Do we already have a 1 where we want it in the first row? Yeah. If I didn't, I might do some swapping to make that happen. Okay, so the next thing, 0 here, 0 here. What would you multiply row 1 by and then add it to row 2? -2 times the first, add it to the second, and now we have to say where we're going to put that.
The second
In row 2. Let's do the same thing. Would you multiply row 1 by and add it to row 3 to cancel out the number there?
Should be 1.
It would just be 1. You don't have to multiply it by anything.
Yeah.
Just take row 1 plus row 3 and replace what's in row 3. Okay, so the only row that's staying the same this time is which row?
The first.
First row. So 1, -1, 1, 0. Okay. What's 1 times -2?
Oh, positive. 2.
-2
Oh, negative.
plus 2. What's -1 times -2? Plus 0? 2. 1 times -2? Minus 3. And lastly, 0 times -2? Minus 1. Okay, so that's good. And the last row, we're just going to add, the last calculation, just add rows 1 and 3. 1 plus -1, -1 plus -1, 1 plus 2, and 0 minus 1. Okay, so that first column is the way we want it. In order to not mess that up, we're never going to use row 1 again. If you do anything with row 1 to these 2 rows, you're going to mess up the zeros.
So when you're doing this, you want to find a column first, right? And once you find one column, you don't want to mess with the first row.
Yeah, once you get the 2 zeros in that column, don't ever use the first row again.
Okay.
So we have to use 2 and 3.
We're going to use rows 2 and 3 for the rest of the problem.
Got it.
Multiply a row by a half.
That's the next
That's
step.
the next one.
So 1/2 times the second row, and we're going to replace what's in the second row. So row 1 stays the same forever. Row 3 stays the same just for this step. And now take half of everything in row 2. So what would that give me?
0, and then 1, and then.
Yep, negative 2 and a half. Negative a half. Okay. All right, so now the next step is to get a what? Where?
You want a 0
Under the one we just made. We've got to get a 0.
row 3, column 2.
Row 3, column 2. So what would you multiply row 1 by to make that happen? I'm sorry, row 2. Yeah, you can't use row 1. Would you multiply row 2 by?
Would it be
Positive 2 times the second, added to the third, and we're replacing which row?
The third.
The third. All right, so copy over 1, negative 1, 1, 0.
1, negative 2.
Yep, you can copy the second row. 1, 0, 1, negative 2.5, negative 0.5, and the last row. First one's just going to be a 0. What's 1 times 2?
2.
Minus 2. And then negative 2.5 times 2. Negative 5 plus 3? Negative 2. And then negative a half times 2. Negative 1
Yes,
plus
negative.
another negative 1. Negative 2. Okay. Now the last step is you want to get a 1 right there.
Yeah. So you want to multiply by a negative a half?
Yep, row 3 times negative a half. Replace what's in row 3, and we are done with the matrix, and we will know our first letter. And the other 2 should be pretty quick. So 1, negative 1, 1, 0. 0, 1, negative 2.5, negative a half. 0, what's negative 2 times negative a half? And then negative 2 times negative a half again is 1. What does that last row tell me? 1z equals 1. What does the second row tell me? Y minus 2.5z equals? Negative a half. Z is 1. So if we fill in 1 for z, you get that. 2. Y is 2. And now we're going to go all the way back to the top row to get x. So what does that top row say? X minus y plus z equals 0. So x minus 2 plus 1 equals 0. What's negative 2 plus 1? So x would equal 1. And that's how you solve a system with a matrix.
Wait, so you put it in it. So you're just like reversing the matrix then? You're like putting it in its form, in its like original form?
Yeah, it's like you're putting the letters back in when you do substitution. This isn't the only way to finish the problem from this step, but it's the way that we did it in class. Z is 1.
And that's because the third row would be 1 equals 1, right?
The third row is
Equals
0x plus 0y plus 1z equals 1.
Okay, yeah.
And 1z equals 1 is just z equals 1.
Yeah.
Once you get z, then you go back to the second row to get y, go back to the first row to get x.
So why you would plug in what you got for z in the second one then?
Yes.
Right? So you would plug it in with the z that's already there, so combine them together?
Well, that's the coefficient of z. So it's the coefficient of z times what you got for z.
Oh, okay. All right.
Yep. Since z was just 1, it didn't change.
Yeah.
Okay, so that, just kind of look at it, the whole step. That's the process. And typically you have to rewrite it about 4 or 5 times. This was the original. And then we did 1, 2, 3, 4 rewritings.
How do you know what those like
These,
Yeah.
they come from the matrix. So this one, that's how I got that one. And then this one is what gave me that. 0x. This column, first column is x, the second column is y, the third column is z. So 0x plus y minus 2.5z equals negative 0.5. And then this is 1x minus 1y plus 1z equals 0. So this third row gives me that one. Yep, so you just use each row.
So when doing a word problem, we would have to,
Yep, now we'll look at a word problem.
oh,
So it's kind of hard for me to make up a word problem with 3 variables, but I can do one with 2 that would be similar to the one that's on the test.
Whatever makes it easy.
yeah, whatever. works.
So unless there's one in the book.
I know there was one for homework that we had to do
I think the
the
one
homework for the
was
matrix.
2 variables, not 3.
Yeah, it was a 2. Well, let's do something with 2. Let's say that the sum of 2 numbers is 20. So the sum of 2 numbers is 20. Now let's say the first plus 2 numers. I'm dealing with numers. Numers and boba. The first number plus, I don't know if this is going to come out nice, we'll see. The first plus 3 times the second is, let's just say 30. Find the 2 numbers. So the sum of the numbers is 20, and the first plus 3 times the second is 30. So if they were going to give you 3 numbers, they'd have to give you a third fact. If I'm only having you find 2 numbers, you only need 2 facts.
So in order to equal-
Okay, so how would you translate this first equation, or this first statement into an equation?
So like x plus y equals 20.
X plus y equals 20. Okay? Now, the first plus 3 times the second. What's the first?
X.
Plus 3 times the second.
Plus 3y.
3y equals 30. And now from here, we just solve it. So we could do a matrix, or we could do elimination or substitution. Probably easier to do
Also, we have a
elimination.
choice to do,
Yeah.
oh, we do.
Wait, on the test.
I thought we had to do a matrix for it or something.
Nope, it doesn't say on the word problem how to solve it.
Oh, well, thank the Lord.
So what equation, actually, you have a lot of choices, but what could you multiply equation 1 by to cancel out when you add it to equation 2? Yeah, if you wanted to cancel the y's, you could multiply by negative 3. So that would give you negative 3x minus 3y equals negative 60. And x plus 3y equals 30. So we just zeroed out the y's. What do you get when you add the x's? Negative 2x. And what about when you add the constants? Negative 30. So what would my first number be? 15. So the first number is 15. How would you get the second number?
Plug it in.
Yeah, I would plug it into
The one that's easier.
the top one. 15 plus y equals 20. So what's y? 5.
I said a wrong number. I'm so stupid.
There's your 2 numbers.
That's how I.
Okay. With a 3 by 3 system, it's a little more work. You could do it like a matrix, or you could do substitution, or you could do elimination. I think when you have 3 variables, a matrix organizes the steps for you better. But if you don't want to do it, you want to do it a different way, that's fine. What if I said, just try to translate this sentence. Let's see. Let's say I said something like, the first decreased by 6 plus, this is just trying to make it as confusing as I could to see if we could do it. The first decreased by 6 plus 5 times the second is 10. How would you write that?
X minus 6
Yep,
plus 5y.
yep,
Change equals
10. Yeah, that's about as confusing of wording as you could have. I don't think there's any quite that bad. Okay. What if they said, I'm just going to change it slightly. The first decreased by, let's do it like this. Let's say the first decreased by twice the second. Plus 4 times the third is 20. So how would you write that one?
So x minus 2y
Decreased by twice the second. Yep.
Plus 14
Plus 4 times the third.
is equal.
Is it this one? Yeah.
Good job, guys.
So if you were going to have one like this on the test, they would give you 3 sentences, and you'd turn all 3 into equations. But they're going to be just like that.
Okay.
Okay, so any questions on what the word like sum means, decreased by, times? If I said the difference, that means subtract. So any questions on those kind of words?
Not right now. Maybe tomorrow, I mean, maybe it's Friday when I'm looking at it.
All right. Next, all the rest of the problems are on the sequences and series. So
I get it.
what if I said, write the first 5 terms. So the first sequence, let's say it's sequence B, and the formula is 2n plus 5. And I want to know the first 5 terms in that sequence.
Do we know what the first term is?
How do you find, so that would be B sub 1. How would you find B sub 1?
2 times 1.5.
Yeah. To find B sub 1, you just change n to 1. 2 times 1 plus 5.
Oh, it's, oh.
Which is
So wait, what is this? This is,
Just writing out,
Sequence system.
writing out terms given an explicit formula. So what's the first term? 7. How would you find the second term?
You would put a 2 instead.
So the, what
N for
would,
n.
yep, what would the calculation be?
Be 2 for 9.
2 times 2 plus 5.
2 times 2
Oh.
plus 5.
Well, so this will equal 9.
And that would equal 9.
Yeah, I just.
B sub 3
2 times 3 plus 5,
plus 5,
which is 11.
which is 11. So you can see the pattern, it's just going up by 2 each time.
Yeah.
Okay, 2 times 4 plus 5 is 13. 2 times 5 plus 5. 15. Okay, so that's it. That's the first 5 terms in an explicit, using an explicit formula. Okay, the other type I'm going to give you is, what's the other type besides explicit?
Recursive.
Recursive. So let's call this sequence C. And to generate the terms in sequence C, it's 2C n minus 1 plus 3. What does that mean to do? Can someone explain, like, if somebody didn't understand that notation, what is it basically telling you to do?
To take the previous term, multiply it by 2, and then add 3.
Yeah, to get a term, take the one before it, double it, and add 3. That's what you do. But what do I have to give you this time to start you off?
The first
I have to give you the first term. Because if you don't know where to start. So we'll say C sub 1 equals 3. And we don't want to confuse that. Let's do 4. 4. So how would you get C sub 2? What would be the calculation?
You have to take 4 times 2,
Yep. 2
or 2 times 4.
times the term before it.
Yeah, and then add 3.
Add 3. So what do you get?
You get 8 plus 3, which should be 11.
And then C sub 3, the calculation would be
2 times 11.
11. Yep. So that goes there.
Yeah, you got it,
Goes there.
and then add 3.
Yeah, why did I see sub n minus 1?
Because that means the term before the one you're looking for. So what's this one? 25? C sub 4. Calculation for C sub 4.
2 times 25, and then add 3.
Add 3.
53.
53, yep. And C sub 5.
2 times 53 plus 3.
So you're just taking the previous one and plugging it in every time.
Yes.
And that would be
109.
109.
109.
Okay. So the disadvantage to the recursive one is to get every term, you need to know the one before it. With an explicit one, you don't. I could jump right to the 50th term if I wanted. Just plug in 50. It would be 2 times 50 is 100, plus 5, 105. And I didn't have to find the 49th term to get the 50th. And I didn't have to find the 48th term to get the 49th. I can find anything I want. That doesn't work that way with recursive.
How do we take a recursive formula and convert it to an explicit?
In general, that's kind of hard to do, but we just have to look at
Need to
it.
do that during the test at all? Or- 'Cause
I'm going to give you some problems that are relatively easy to find explicit formulas.
Okay.
Because in general, converting recursive ones to explicit is hard.
Okay.
Yeah. It's
Yeah,
not.
but I don't know, I think there was maybe it wasn't a homework question, but I saw a question, like, it had a recursive formula, but it was asking for a term that was really high. Like
Yeah, this one would be
37 terms
tough
or
to
something
do.
like that. Yeah,
It's doable, but not quite something we looked at.
okay.
So the next one, we're going to touch on this more tomorrow, but determine whether the sequence converges or diverges. So the idea here is converges means that when you look out at the terms further and further and further, you keep looking at them, they're approaching a number. If they're approaching infinity, then we say it diverges. All right, so let's say we had the sequence, let's go 3, 6, 12, 24, 48. And I'm going to put dot, 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 because it just keeps going. So if you continued to look at that sequence further and further down, what would the numbers be approaching? Infinity. So are they converging to a number or diverging? They're diverging. Okay, they're not approaching a number, they're approaching infinity. So this is diverges. You say it diverges.
So diverging is a increasing value then, that's going to.
It approaches infinity. Now, if you had a sequence like, let's say,
So all I have to do in like this part of the test would be determine if the numbers are getting infinitely big or infinitely small towards a certain number, right?
yeah.
So if they're fractions, they're converging.
So what am I doing there each time?
You're getting closer to 0 because they're decreasing.
And what specifically did I do to get from one step? It took half of it. Took half, just keep taking half each time. So if you continue to look at this further and further down, eventually this number is going to get closer and closer to what? 0. So we say that converges because it's approaching a number. Okay, so we look more at that tomorrow, but that's the idea. Diverges approaches infinity, converges, it gets closer and closer to a number. Okay, next type, it's the one we were just asked about. We're going to find an explicit rule for the sequence. Not recursive. Okay, a lot of people on these, they do a recursive rule, and I mark it wrong because the directions say explicit. So, let's find an explicit. All right, let's try one that's an arithmetic and one that's a geometric. So how would I generate an arithmetic sequence? What does that mean that I do each time?
You're adding.
Sure, adding or subtracting.
Is one where you use that E symbol?
No, that's sigma notation. That's with summations. So that's the next lesson.
Oh.
Yep. So let's do this. Commas. What's the pattern here?
Plus one.
Yeah, I'm just doing +3 each time. So let's find a formula for that. All right, so I've got my first, second, third, fourth, fifth. Now, you can try to guess and figure it out, which it really isn't that hard to do here, but we had a formula in the notes that as long as you know what you're adding each time, we called that D. It was called the common difference.
Yeah.
And you know the first term, you can figure it out. You don't even need to think about it. You just plug into a formula. One of the formulas had a D for common difference. One of them had an R for common ratio. Anyone remember the formula that had D in it?
First term plus n minus 1 parentheses.
First term plus n minus 1
And then D on the other side.
times D. So just fill in, and that'll give you the formula we're looking for. First term is what?
9.
How much? 9. Yep. And what's the common difference here?
That'd be
3.
3. So let's do that out.
Distribute.
Yep. What do you get when you distribute?
You get 3 and minus 3.
3. And my final answer?
3 plus
3n
6
plus 6. Let's try it. Let's generate our fourth term and see if it works. What's 3 times 4?
12.
Plus 6? Yep, that works. Let's try the third one. 3 times 3?
9.
9 plus 6? 15. So if you wanted the 10th term, what would the 10th term be?
36.
36. 3 times 10 is 30 plus 6. And you could find the 10th one without finding the 6th, 7th, 8th, or 9th. You can just jump right to the 10th because that's explicit. Okay, so that's what I would be looking for.
Mr. Hager, is that like one of the formulas we should know?
Yeah,
A and
that seems like something.
Yep, you definitely should know that. Let's call that 5A, and then let's look at another one. So along the same idea, still find an explicit formula. Let's do geometric. What's a geometric sequence?
Or it's multiplying.
It's multiplied. It's actually, I had one right here. 3, 6, 12, 24, 48. 3, 6, 12. Okay, so this, there's a formula for as well. Now you can't say that it's the previous term times 3. Because if you did that, what kind of formula would that be?
Or,
Recursive.
That would be recursive. If you just say take the previous one and multiply by 3.
Pretty sure I thought it was it.
They want explicit. Okay, so explicit, that formula has an A sub 1 in it and an R. Does anybody remember the formula for that?
First term times the common ratio. And n minus 1.
A sub 1 R to the n minus 1. So in this case, first term is 3. Common ratio, 2 to the n minus 1. You cannot do 3 times 2 and write 6. Okay, PEMDAS, you have to do exponents first. So let's try to generate our fourth term. What's 4 minus 1? 3. What's 2 cubed?
8.
What's 8 times 3? 24, that works. You could check it on another one too.
I was gonna say 64, but I was like, why am I, oh, it's 64.
Okay, so any questions on how to generate a explicit formula from either an arithmetic or geometric sequence? All right. The next thing is what Luke mentioned a few minutes ago, sigma notation. So now we're getting into a series. With that, okay. So let's.
Wait, here's a question.
Yep.
N is always the number term, right? That's the.
It's the term number.
Okay.
Yep. And term numbers can't be negatives and they can't be decimals.
Okay.
So if we're looking for the fourth term, we're just plugging 4 for it.
Yes. All right, let's try. All right, let's try this. Let's take a sequence we just had, 9, 12, 15, 18, 21. And the directions are going to be to write this. I'm going to put pluses between it. Write this in sigma notation. And I got to stop somewhere. So I'll do one more term. We'll stop there. So that's the first, second, third, fourth, fifth, sixth. So write in sigma notation. All right, first thing you have to figure out is the formula for those numbers. Okay? We already did that in the previous page. So the formula that generates these terms is 3n plus 6. Any questions on how we got that? Okay, that's the first step. Now we have to decide where, and you know what? Usually we use the letter K. It doesn't really matter. But what would be my first value of K? I would plug into that formula to get the first term. 1. What would be my last value for K?
Would that be like your last value?
The last value for K,
Well, that would be 6.
6. What I just circled is exactly what I wrote up above. Because if you plug in 1, you get 3 times 1 is 3, plus 6 is 9, and then plus, now you go to 2. 3 times 2 is 6, plus 6 is 12.
So you can't write it in sigma if it's a pattern.
You can. Yep, if this was infinite, I would go like this. This is what we're going to talk about tomorrow. I would just say keep going, don't stop. That's all.
So sigma notation is just to write
A sum.
a sequence in a different way, right?
It's to write a sum. It's to take all the numbers in a sequence and add them together.
Oh, okay, so 9 is just the first number of the sequence, but all the other numbers are other numbers and they're just adding them together.
Yeah, that'd be the first number, the second number, the third, and so on, and we're adding them. So I just changed it to infinity because Alex had asked me, what would you do if it was infinite? You would put infinity at the top of your summation. But that's tomorrow. The ones we did today didn't have the dot, dot, dot in sigma notation. They stopped somewhere. Okay, now, I want to show you a different way you could write the same answer. I want to start at 0. And instead, I'm going to go to 5. So, when you plug 1 in for K, what are you supposed to get the first time?
9.
You're supposed to get 9. So, what you can do is if you make this 1 smaller, you can balance it by making this what? How would you balance that out? If you make this number smaller by 1, you'd have to make this. That wouldn't balance it.
Bigger than 1.
bigger by 1. So if you did this, let's see what happens if you plug 0 into this formula. What's 0 plus 1?
1,
And what's 1 times 3?
3,
Plus 6?
9.
9. There's your first term. Now the next one we started at 0, now we're going to go to 1. What's 1 plus 1? 2. Times 3? 6 plus 6 is 12. So these two formulas are exactly the same thing. What we did is we changed the index. So instead of starting at 1, we started at 0. You might have to do something like that on the test. But keep in mind, it's just balancing. So if you make this number 1 smaller, make that number 1 bigger. Once you find a formula that works.
So, well, let's say I want to make it like 2 smaller. Like,
All right, we can make it 2 smaller. If you make this 2 smaller, you have to make this 2 smaller. So what would that be? 4. And you have to make this 2 smaller. Balance it, 2 bigger.
So it's k plus 2.
K plus 2 plus 6. Now watch what happens if you plug in negative 1. What's negative 1 plus 2?
1,
And 1 times 3?
3.
And 3 plus 6. Yeah, there's your first term.
Oh, so you just have to make everything.
So once you make one thing smaller, you have to make the things.
Yeah, you got to just keep it balanced. If you make the numbers on the sigma smaller, you got to adjust the number on the k to be bigger.
Okay.
All 3 of those are exactly the same.
I totally
Will
forgot.
that be a thing on the test?
Yep, something like that will probably come up. Because there'll be a multiple choice answer where I start at 0, and a lot of people are used to starting at 1. You're going to have to convert yours. And if you wanted, you could distribute it and make it 3k plus 3 plus 6. So it's really 3k plus 9.
Yeah.
You could adjust that. This one is really 3k plus 9. This one is really 3k plus
So it's
12.
gonna be one of those times where we have a certain answer, but it could be in a different.
It could be in any one of those forms.
Yeah, okay.
They're all going to be 3k plus something.
Yeah.
3k plus 6, 3k plus 9, 3k plus 12. Yeah, it just depends on where your index starts.
Yeah.
Sounds good.
I think I need to work on that.
Okay, and the last thing that we can really go over is finding the sum of the first n terms in a sequence. So let's take let's do this one.
So what is it here? I'm finding the sum.
I'm going to do one that we can do by hand, and then I want to do one like the last problem in class. So find the sum of the first 4 terms. I'm going to keep it small so we can do it easily. Let's do 7, 9, 11. And let's say that's all, excuse me, all I give you. If you wanted to do it by hand, well, you'd have to find one more term. What's the term we're missing? 13. And now you can just add those up. Okay, so if you want to do it by hand, you have to find all the terms you're missing up to however high they want you to go. In this case, I just needed one more. And then add them up. What's 7 and 9? So we get 16 plus 11 plus 13. What's 16 and 11? 27 and 13, which is 40. So that's all you have to do to add up terms by hand. If it said find the first 8 terms, I'd have to list out a few more. Okay. Now let's try find the sum of the first, let's do 25 terms. So now if you're getting into one that's that big, you're going to want to use a formula. Probably not going to want to do that by hand.
I can do it by hand.
You could?
Yeah.
Take a
Good.
while though.
It might take a while, and you could make a mistake.
I don't make mistakes.
You don't?
You are a mistake.
Wow.
This is a video.
That's not nice, Alex. That's not nice. So let me pick something geometric. So let's do 5, 10, 20, 40, and I want to do the first 25 terms. So I'm not going to keep listing them. At the end of class today, we had a formula to find the sum of a geometric sequence. What was the formula to find the sum of a geometric sequence?
To find the sum. Oh, it was like 1 minus r, right? Is that formula?
Yep, that was part of
Oh,
it.
yeah, yeah, yeah.
That was the denominator.
First term. And then 1 minus r to the n power.
And where was the n? Inside or outside the parentheses? Inside. Great. So if you fill that out, we can add up the first 25 terms. What's my first term? 5. And what is the common ratio here?
2.
2. 1 minus 2. And now it's to the n. And n would be what number in this case? 25. All right, so it would be 5 times 1 minus 2 to the 25th power. That's going to be kind of big. 1 minus 2 to the 25th power. So,
Oh.
X.
Oh.
300. No.
I don't even know what that number is.
it's not that big, but negative 33554431. So,
That's not big.
I mean, millions. It's not super huge, but it's pretty big. So it's 5 times negative 33,554,431 divided by
Negative 1.
negative 1. All right, so I'm just going to type that in. Times 5 divided by negative 1. Okay, so we get
My bank account.
1677. That's your bank account?
One day.
Negative.
I'm in debt that much.
1, 2, 3, 1, 2. Okay, so that's the answer. So you could check it, but it would take a while to check that by hand. You'd have to do 5 plus 10 plus 20 plus 40 plus 80 plus 160 plus 320. But it starts getting pretty big. I mean, look at how big it gets after 80. Just if you go like 5 or 6 numbers after that. 1, 2, 3, 4, 5, 6 numbers after it, it's already 5,000. And we're going, what would that be? 6, 7, 8, 9, 10, 11. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. That's the 25th number. So, I mean, they're getting pretty big. And if you add them all up, it should be 167 million. Okay? But not something we really want to do by hand. All right, so the last 2 things that are on the test are things we're going to talk about tomorrow. It ties in with the idea of converging and diverging, but it's not asking if a sequence converges or diverges. It's whether or not a series converges or diverges. Okay, so that'll be what we go over tomorrow. So, any questions on what we did? Okay, so that covers everything except the last 2 questions. So the test will be 12 questions. 11 and 12 we'll do tomorrow.